Hello, dear students. Welcome to Solid State Physics. I'm Dr. Pervaiz Ahmad. From today's, we will start the first sections of the Solid State Physics, that is crystallography. This is lecture number first. In this lectures, we will have a discussions on the type of material. That is, we will do the discussions on the solid materials. In the solid material, we will have brief discussions on the crystallines, polycrystalline and amorphous material. Let's start today's lecture. Before to go into a full detail of the lectures, let's have a brief overview on matter type regarding the solid state physics. So in solid state physics, normally we talk about three type of the solid, that is gases, liquid or liquid crystal, and solid. So these are the three type of matter that normally we discuss in solid state physics. I mean, you know that there are basically four type of matter. We have plasma as well, but here it's not a matter of concern for us in this course particularly. So we just trying to differentiate solid from the gases and liquid, so that's why we have taken only three form of the matter. So what are the gases? So you know that gases have atom or molecule that do not bond to one another and a range of pressure, temperature, and volume. So this is a formal definition for the gases, and you know that these molecules have any particular order and move freely within a container. So just like you can see it here, you know that the gas molecule, they are free to move about when you live at a container. Uh, as far the liquid is concerned, liquid and liquid crystal, so similar to gases, liquid haven't any atomic molecular order, and they assume to they assume the shape of the container. I mean, as far the liquid is concerned, so liquid by itself, it do not have any proper shape, so it normally take the shape of the container and which we put them. There is no proper shape of the liquid as well. So applying low level of the thermal energy can easily break the existing weak bond. So this is the another feature of the liquid. If we just apply I mean some sort of the pressure, I mean thermal energy, so it can easily break the weak bonding between the liquid molecule. So liquid crystal have a more mobile molecule, but a type of long range order can exist. The molecule have a permanent dipole, and by applying an electric field, I mean rotate the dipole and establishes order within the collections of the molecule. I mean this is a definition for the liquid crystals. You know, one type we will discuss about the crystals, in which we will say that it has a particular patterns or order. So what about the liquid crystal? So liquid crystals, it has a mobile molecule. I mean it's a type of long range order can exist in this type of the molecule, but we remember these molecules have a permanent dipole moment, and by applying an electric field, it rotates the dipole and established order within the collection of the molecule, and a sort of order of the this type of the phenomena you can see it here in this particular figure. So what is crystal? So a crystal consists of atom or molecule executing thermal motion about an equilibrium position fixed at a point and a space. So this is somehow a very formal definition of crystals. We remember we will have a detailed discussions once we start the course. I mean this is just a formal definition for introductory purposes. So solid can take the form of a crystalline, polycrystalline, or amorphous materials. I mean later on in this lectures, uh, we will have a discussions on the we will discuss what is mean by the crystalline material, what is mean by polycrystalline material, or what is mean by the amorphous material. Not only in this lecture but also inside the course, we will have a detailed discussion on all these type of the materials. So solid at a given temperature and pressure and volume have a strong bond between the molecules and atom than the liquid. So this is, I mean, another characteristic of the solid. That is, solid molecule, they have a very strong bonding between the molecule and its atom, and this is far stronger than compared to the liquid. uh, uh, this is another characteristic of the solid. So solid require more energy to break the bonds. I mean, here we are saying that it has stronger bond. So stronger bond mean that more energy is required to break the bond. I mean, they are that's why, I mean, it's the solid material, the atom are very closely bond. I mean, very closely related to each other. So therefore, we need more energy to break the bonds. Now let's come toward the the type of the material with respect to the crystallinity. With respect to the crystallinity, the materials they are classified into three categories. The first one we call that crystalline materials, which also include single crystals. Then we have polycrystalline materials and amorphous materials. So each type you can see here in the photograph. So now let's move towards one by one discussions of the type of the solid. So single crystal, polycrystalline and amorphous are the three general type of the solid that you people have already seen on the previous slide. So each type is characterized by the size of the outer regions within the material. An ordered region is a special volume in which the atoms or molecules have a regular geometric arrangement or periodicity. That again we will discuss further. So let's first come toward the crystalline solid. So what is mean by the crystalline solid? So crystalline solid is the solid form of a substance in which the atoms or molecules are arranged and a defined repeating patterns and a three dimensions. So here you can see the example. I mean, this is the example in one dimensions, this is in two dimensions, this is the and three dimension. This is the regular periodic arrangement of the atom. So if the atom they are arranged in this particular patterns, so we call them as a crystalline solid. So we remember single crystals ideally have a high degree of order or regular geometric periodicity throughout the entire volume of the material. So again you can see this periodicity here, not only here but also here. Crystalline solid, let me explain further. Single crystal has an atomic structures that repeat periodically across a whole volume. Even at an infinite length scale, each atom is related to every other equivalent atom and the structures by translation symmetry. So what is mean by translation symmetry? If you have a crystals and you want to rotate it in a particular dimension, so let's suppose it repeat its uniformity in all the directions. So we call that that crystal it maintain that particular symmetry. I mean, here you can see that if you look at the crystal from the top, from the side, from this side, from the left hand side, and from the right hand side, so from all the direction it would look the same. So it would mean that it has symmetry in all the direction. That's why, I mean, if you rotate it, rotation doesn't mean all the sides it will look the same. So just like this one, so that is called the symmetry. So this is another characteristic that we will discuss later on in the course. So what is mean by polycrystal or polycrystalline? So polycrystal is a materials made up an aggregate of many small single crystal, also called crystallites or grain. So here you can see, I mean, we have small regions. Within small regions, inside a big crystals, we have small crystals, and within a small crystal the arrangement are of the same kind. So what are these small crystal? Are these small region within a big crystal? So let me explain it again. So polycrystalline materials have a high degree of order over many atomic or molecular dimensions. These order regions or single crystal regions vary in size and orientation with respect to one another. These regions are called as grains or domain. and are separated from one another by grain boundaries. The atomic order can vary from one domain to the next, and here you can see it here. I mean, you can also observe here, but here it can clearly be identified. So here you can see we have this region. So in this region the arrangement of the atoms, they are of one kind, and here it is of another kind, and here is of another kind. So each region is separated from one another with the help of a line. So these are basically called the grain boundaries, and these locations, they are basically what they are basically the grains are the domains. I mean, these different location inside a big crystals, we call them grains, or we can also call them domains. So these domains, they basically they are many crystal uh, within a crystal, a big crystal. So these are many crystal. So that's why we call that polycrystalline solid. I mean, what it mean that when inside one solid, we have different kind of the crystal structures. So that's why we call them as polycrystalline materials. We remember these grains. I mean, here you can see these grain boundaries are these grains or domains are usually from 100 nanometer to 100 microns in diameter. I mean, this is the range of the grains inside a polycrystal. And polycrystal with the grains that are smaller than 10 nanometer in diameter are called nanocrystalline. So we have grain boundaries. We have grains or domain size that lies in the range of 100 nanometer to 100 micrometers. And if we have a crystals with a dimension smaller than 10 nanometers in diameter, so that we call nanocrystalline. So that you have to remember. Now what about the amorphous materials? So amorphous material, we can also call them non-crystalline solid. So this is the material which is composed of randomly oriented atoms, ions or molecules that do not form defined patterns or lattice structures. I mean, it is a form of the solid where the atoms are irregularly arranged. I mean, there is no particular patterns in the atoms of the material. So amorphous material have order only within a few atomic or molecular dimension. I mean, you can see the order at a very small scale, but that should be so at a very small range. And amorphous material do not have any long range order. I mean, we can see some short range order, I mean within 2 or 3 atoms or molecule, but we remember this is not long range order. And we remember they have the varying degree of short range order. Example to amorphous material include amorphous silicon, plastic, and glasses. Amorphous silicon can be used in solid cell and thin film transistor. I mean, we remember amorphous material also has its uses. I mean, it's also important in some particular application, just like I have mentioned about the solar cell or thin film transistor. So amorphous materials, is also important, just like the crystalline materials. Departure from perfect crystals, we remember perfect crystals to be saying, and that do not exist in the nature. I mean, according to uncertainty principles, they are be taking and the physics. So strictly speaking, one cannot prepare perfect crystals. For example, even the surface of a crystal is a kind of imperfection because the periodicity is interrupted there. Another example concerns the thermal vibration of the atom around their equilibrium positions for any temperature greater than 0 Kelvin. So as a third example, actual crystal always contains some foreign atom, that is impurities, and these impurities spoils the perfect crystal structure. So that's all we have for this lecture. Stay tuned for the next lecture. From that lecture, we will formally start the crystallography, and we will start the discussion from the question what is crystallography. So stay tuned for the next lecture. Till then, Bye bye.